All right, we're looking at 9.2 today. We're doing more area and perimeter stuff. We're basically taking what we did in 9.1 and we're just adding a little more complexity to it. So in 9.1, you had to identify the shape, identify the formula, and identify all those parts in the shape that you need to do the formula, and then complete the formula for area or perimeter. Today, we're just going to add the complexity where sometimes some of the things you need for your formula aren't given to you. You have to find them. And so we're going to have to do a little extra work to find the pieces that we need so we can plug those into the formula. So this is just a quick reminder of what the formulas are so that you have those available to you. Let's go ahead and look at example 1. All right, find the indicated measures, round to the nearest hundredth. So we are looking at a rectangle and we want to find the area and perimeter. At the moment, however, we don't have any of the sides. So we're going to have to do a little work to find those missing sides first. We need the length and width so that we can do the formula for area of a rectangle, because area is length times width. And then we need the sides for perimeter because we got to add up all the sides. So we got to get some work done to do that. So notice that they have drawn a diagonal through the rectangle, and the length of the diagonal is 4. And thank goodness this angle right here is 30 degrees. So when you draw a diagonal through a rectangle, it splits it into a couple of right triangles. And in this right triangle, I know one of the sides, and I know an acute angle. I have enough information that I can do a little trig to find those missing sides. So if you remember earlier in the year, we memorized SOHCAHTOA, which means that the sine of an angle is equal to the opposite over hypotenuse. Cosine of an angle is the adjacent over the hypotenuse, and tangent of the angle equals the opposite over adjacent. So I'm going to focus on this right triangle right here, and I'm going to label my sides. So opposite the right angle is the hypotenuse. So that 4 is the hypotenuse. I'm going to use this 30-degree angle. We always use one of the acute angles. Don't ever use the right angle. And opposite the 30 degrees would be this side over here, and that would make this side the adjacent side. Now, if I'm going to set up equations to solve for these missing sides, I need some variables here. So I'm just going to call the opposite x, I'll call the adjacent y, and we'll set up some equations to find these things. So if I want to solve for x, then I do not want to include y in my equation because I want x to be the only variable. So that means I'm using the opposite and the hypotenuse. So opposite and hypotenuse, I need to use sine. Sine is the only trig function that will use opposite and hypotenuse. So I'm setting up my equation with sine. So it's sine of the angle, 30, equals the opposite over the hypotenuse. And there's my equation. So I can solve for x now. X is currently being divided by 4. So I'm going to do the opposite operation and multiply by 4 to get x all by itself. And if I do that on one side, I need to make sure I'm doing the same thing to the other side. So I'm doing 4 times the sine of 30, and that comes out to exactly 2. So I just found out x is 2, and that would be my width, 2 units. And now we need to find the length. We got the width, now we need the length. So if I want to set up an equation to solve for y, I do not want to include x. I want y to be my only variable. So that means I'm using the adjacent and hypotenuse. So adjacent and hypotenuse requires me to use cosine. Cosine uses adjacent and hypotenuse. So I'm setting up my equation with cosine. So cosine of the angle, 30, is equal to the adjacent over the hypotenuse. And then once again, I'm solving for my variable. The y is being divided by 4, so I do the opposite, multiply by 4. And I'm just typing this in the calculator. 4 times the cosine of 30. And I got 3.4641. It's an irrational number, so I got to round somewhere. Now we want to round our final answer to the nearest hundredth. So for now, I'm going to keep a few extra places because I don't want it to affect my final answer. So I now have the length and the width. I have everything I need to do area now. Remember, area is just length times width. So I'm just multiplying that length times width. And when I multiply those, Get something like this. And so when I round to the nearest hundredth, I'm keeping 2 places after the decimal. There are 2 zeros in the number 100. 8 is big enough to round up, so that last number I'm keeping needs to increase, and so it goes from 2 to 3. And so I would say my area is approximately 6.93 units squared. Then we also want to do perimeter, and for perimeter we just add up all 4 sides. So the 4 sides, we have 2 and 2, and we have 3.4641 plus the other 3.4641. We're just adding up those 4 sides. And when I add all those up, I got 10.9282. So rounding to the nearest hundredth, keeping 2 places after the decimal. That 8 is big enough I need to round up, and so that will make this 10.93 units. And remember, perimeter is plain old regular units. It's one-dimensional. Area is two-dimensional. Units squared. All right, let's look at number 2. Okay, we're clearly looking at a triangle on number 2. So area of a triangle is 1/2 times base times height. We need the base and the height. Now remember that base and height, they're always perpendicular. Always perpendicular. So you'll notice there's no right angles currently in this picture. So when sometimes the height is not already drawn for you. So if I'm going to make this the base, then the height has to come right through here, perpendicular to that base. So this is the base, and this is the height. Now I should already know what the base is because this triangle had all 3 sides marked congruent for us. So if that's 8, this is 8, and so is this side. Now, when I draw the height in here, it splits this larger triangle into 2 smaller triangles. And I know that these triangles are congruent by a hypotenuse leg because this is the hypotenuse of this right triangle. This is the hypotenuse of this right triangle, and they're congruent. And then they are sharing this leg, so those are congruent legs right there between the 2 triangles. So by hypotenuse leg, I know these 2 triangles are congruent to each other. Therefore, I know that this 8 down here is going to be split into 2 equal halves because these corresponding sides have to be congruent as well. So, if I focus on this right triangle, I now have 2 of the sides of that right triangle. I can find that 3rd side, which is my height, by doing Pythagorean theorem. And anytime we have 2 sides of a right triangle, we can get the 3rd side by doing Pythagorean theorem. So again, the hypotenuse is opposite the right angle, so 8 goes in for C. The 4 can go in for A or B. It does not matter which one. So 4 squared is 16. 8 squared is 64. We want to solve for A, so I want to get it by itself. I'm going to subtract off this 16. 64 minus 16 is 48. And then we got to get rid of this squared, so we do the square root. And the square root of 48, 6.9282, and so on. This is an irrational number, so we got to round somewhere. So what we just found is the height. So we already knew the base was 8. We just found out what the height is. So now we want to get the area and perimeter. We got the base and height, so we're ready to get the area. So base was 8. Height is 6.9282 approximately. So we'll go ahead and put that in the calculator. Multiply that height times 8 and times 1/2. And we get something like this. So when we round it to the nearest hundredth, I'm keeping 2 numbers after the decimal. Next number is a 2. That is not big enough to round up. So we'll keep it as 27.71 area units squared. Always two-dimensional, always units squared. Alright, and then for perimeter, we're just adding up all 3 sides. Triangle has 3 sides, 8, 8, and 8. All the sides were congruent, so you can add 8 plus 8 plus 8, or you can just multiply it by 3, doing the same thing either way. So the perimeter is 24 units. 24 units around this. Make sure you are not adding that 6.9282 because that is not a side. That was only the height. Alright, looking at number 3. You'll notice that all the sides are congruent, so I'm identifying this as a rhombus. So for formula for area of a rhombus, we do 1/2 times diagonal 1 times diagonal 2. So we're going to need to find the length of the diagonals. That should be easy right here. This diagonal, 5 plus 5 is 10. This diagonal, 2 plus 2 is 4. And so we're able to get the diagonals pretty quick and easy. So go ahead and substitute those into the formula for area. So 1/2 times 10 is 5. 5 times 4 is 20. And so the area of this rhombus is 20 units squared. Now we also need to get the perimeter, and this is where we actually have more work this time because we don't know any of the sides yet. But in a rhombus, the diagonals are perpendicular. So when you draw these diagonals in here, it splits the rhombus up into right triangles. And notice on this right triangle, we already know 2 of the sides. This side's 2, this is 5. Anytime they give you 2 sides of a right triangle, you can get the third side by doing Pythagorean theorem. Now the side that we're missing right now is the hypotenuse. So the 2 and 5 are A and B. So I'm substituting those in for A and B. And we're solving for C. So 2 squared is 4, 5 squared is 25, 4 plus 25 is 29. And then I want to get rid of the squared, so I do the opposite operation, and I take the square root. And we'll do the square root of 29 is 5.3852. And I ran out of room right there. This is an irrational number, so it keeps going. So if this side is approximately 5.3852, and there's 4 of those sides, for the perimeter, I'm just taking that number and I am multiplying it by 4. I mean, I can add it to itself 4 different times, but no reason to do that. When I can just hit times 4, and I got the perimeter is something like this. So if we are rounding to the nearest hundredth, that 0 is not going to be big enough to round up. And I'll get 21.54. So side length, 5.3852, perimeter 21.54, and this is plain old units on both. They're both one-dimensional measurements. Alright, let's look at the next one. The next one is called a trapezoid. I know it's a trapezoid because these sides are parallel and these sides are not. They are marked congruent, but they're not parallel. So when you only have one pair of parallel sides in that quadrilateral, that makes it a trapezoid. Alright, so for a trapezoid, area is 1/2 times the sum of the bases times the height. Alright, at the moment, remember the bases are the sides that are parallel to each other. So this is a base and this is a base because they're parallel. At the moment, I don't know the length of this base, and I also don't have the height. I don't know what the height is. This is not the height because notice it is not perpendicular to the base. It's not forming a right angle with the base. Now every trapezoid can be split up into right triangles and rectangles when you drop the height down. So if I drop the height here, I can drop the same height here, and it splits that trapezoid up into right triangles and rectangles. So if I just focus on this right triangle here now, I can do some trig. I can use my SOHCAHTOA knowledge to find these missing parts that I need here. So make sure we have SOHCAHTOA visible if you still need help with that. So labeling the sides, the 8 is opposite the right angle, so that is the hypotenuse. I'm going to use this 60-degree angle. So over here, the height of the trapezoid will be the opposite side, and then this piece right here will be the adjacent. So again, I need some variables. So I'm going to use x for the opposite side, y for the adjacent side. And let's set up some equations to find out what we have. So if I want to set up an equation for x, I am not going to use y because I want x to be the only variable. So opposite and hypotenuse, got to use sine. So sine of the angle, 60, is equal to the opposite over the hypotenuse. So there's our equation to solve for x. X is being divided by 8, so I'll multiply by 8. So I'm doing 8 times the sine of 60 is 6.9282. Alright, so this x is the height of the trapezoid. So now we have that. Then we also need to know what this piece is right here. So if I'm going to set up an equation for y, I will not use x. So that means I have to use the adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So I'm doing cosine of the angle is equal to the adjacent over the hypotenuse. Y is currently being divided by 8, so I'm doing the opposite operation, multiplying by 8, so I can get y by itself. And 8 times the cosine of 60 is 4. So I know this right here, this y is 4. Alright, so I found the height, 6.9282. We already knew one of the bases was 12 units. And we just found out this piece is 4. Now I still need this full base. Well, remember in a rectangle that opposite sides are congruent. So if that side is 12, then this side will be 12. And if you notice that these are marked congruent, and the height here and here have to be the same. The height of the trapezoid is the same whether you draw it here or here. So once again, right triangles, hypotenuses are congruent, legs are congruent. By hypotenuse leg, I know these two triangles are congruent to each other. So if this little piece here is 4, this has to be 4, because those are corresponding sides of congruent triangles. So now that I have all of these little parts here, I can add all those up to get that full side. 4 plus 12 is 16. 16 plus 4 is 20. So that full base down here is 20 units. And I finally have all the parts that I need to be able to find the area of the trapezoid. So the bases are 12 and 20, and the height is 6.9282 approximately. Alright, so let's type this area formula into the calculator. And when I type all that in, I get an irrational number that looks something like this. So when I round to the nearest hundredth, keeping two numbers after the decimal, it'll be 110.85 units squared. 1 is not big enough to round up. Alright, and then perimeter is just adding up all the sides. Make sure we understand a trapezoid is a quadrilateral. There's only 4 sides here. This side is 8, this side is 12, this side is congruent to this one, so it'll be 8, and then this side was 20. So we had 8, 12, 8, and 20. Those are the 4 sides. Make sure you're not adding up the height in here. So 8 plus 12 plus 8 plus 20. So it's 28, 48. So perimeter is 48 units. Alright, and the last one for today. This one is a little bit more of an algebra review because we're not going to be able to find actual just plain old numbers for these things. They're going to be expressions. You'll notice that all the sides are marked congruent. So the length is x minus 2, and the width is also x minus 2 because they are congruent. They're all the same. Alright, so for area of a square, you can look at this 2 different ways. Length times width, or side squared. Because all the sides are square, congruent, it is a square. So you're just doing side squared. And each side is x minus 2. Well, when you have a binomial like this and you square it, you can't just square each individual thing. When you square something, it is multiplying times itself. So x minus 2 squared is x minus 2 times x minus 2. When you square something, you're multiplying it times itself. And to do that, we have to distribute the x to everything in this parentheses, and we have to distribute the negative 2 to everything in that set of parentheses. We can be called FOIL because you're multiplying the first thing, you're multiplying the things on the outside, multiplying the things on the inside, and then multiplying the last thing in each set of parentheses. So we're doing x times x is x squared, and x times negative 2 is a negative 2x. So we have distributed the x. Now we distribute the negative 2. Negative 2 times x and negative 2 times negative 2. Once you have finished multiplying them, then you're going to need to combine like terms right here in the middle. You have a negative 2x and another negative 2x, so you got negative 4x. And there is the area. Then for perimeter, we add up all the sides. So for perimeter, each side is x minus 2. So I can do x minus 2 plus x minus 2 plus x minus 2 plus x minus 2. Or I can take that one side and multiply it by 4. I got 4 congruent sides. I can take whatever that side length is and just multiply it by 4. Now when we do that, we have to distribute this multiplication. So we're doing 4 times x is 4x. 4 times negative 2 is negative 8. And there is the perimeter. Now, we don't want to neglect including our units just because these things look a little different than what we're used to. The length is a one-dimensional measurement, so it'll be regular plane units. The width, regular units, one dimension. Area, however, is a two-dimensional measurement, so it is units squared. And then perimeter, one-dimensional, so regular units.